everyone, did you know that Nick has been asked to make a report on the swimming speed of students in class 7 to register them for the swimming competition, and for this he needs to figure out who can swim the fastest over a distance of 25 meters. He has already collected the data from the school records. So Nick, why don't you show us the collected data? The time taken by students is this. Do you think he has completed his work? No. We already know to come to any conclusion he needs to organize this data first. He has organized the data in a frequency table in this manner. On the basis of this report, can you now decide who can participate in swimming competition? Yes, we can. So, he may now submit his report on the class's quickest swimmers. You already know that this data can be represented in many ways for easy reference, like a pictograph, a bar graph. We can look at the bar graph and make inferences about the data. We can also get information based on these bar graphs. For example, we can say that mode of this data is the observation of the highest bar. We know that a bar graph is a representation of numbers using several rectangular bars of uniform width, which are drawn horizontally or vertically with equal spacing between them. Each bar indicates only one category of the numerical data, as the bar for 24 seconds represents the corresponding number of students, which is 4, and in the same way the bar of 25 seconds shows the height according to 7 students, and so on. The height of each bar shows the corresponding value of the numerical data. Look at this data now. In this data, the number of students is given. To draw a bar graph for this data, we need to look at the greatest observation, that is 135. We generally choose a scale as 1 unit length equal to 10, 100 observations, but we can always take a different scale as per requirement. So, we can choose a scale of a unit length equal to 10 for this data, or we can choose the scale of 1 unit length equal to 20 also. It is easier to understand the graph if the height of bars is up to 5 to 8 unit lengths. So, in this question, 1 unit length equal to 20 is a better scale. I am sure you will be able to answer this question. You have learned how to draw a bar graph in the previous class already. Now, if you have this bar graph which shows the population of India from 1951 to 2001, and in this graph you can see the population of China from 1951 to 2001. We can find out what was the population of the countries in a particular year, and you can see the growth in the population. But if you need to know if the speed of growth of population is the same for both the countries, then you need to compare the data. For this, you need to combine these two graphs and draw a double bar graph. Double bar graph helps us to compare two data groups. A double bar graph looks like this. You can easily infer that although there was growth in the population of both the countries, but gradually the population growth reduced in China and the difference between the population of India and China also reduced. Let us check if you can also compare the data presented in a double bar graph using this question. I am hoping you guessed correctly. Let's summarize what we have discussed. Bar graph is a representation of numerical data by using several rectangular bars of uniform width which are drawn horizontally or vertically with equal spacing between them. Choose a scale as 1 unit length equal to 10, 100 observations, but a different scale can be taken as per requirement. Double bar graph helps us to compare two data groups. Stay tuned to learn about chance and probability in the next module.